Hello and good day to you. Come, pull up a chair as we venture into exploring the fascinating subject of agent laboratory, using LLM agents as research assistants. This intriguing research comes to us from the collaborative minds at AMD and Johns Hopkins University. Imagine, if you will, the traditional process of scientific discovery, often lengthy, costly, and demanding substantial time and resources from inception to results. Now, consider a framework that aims to accelerate this process, reduce costs, and enhance the quality of research. This is precisely what the Agent Laboratory sets out to achieve. At its core, the Agent Laboratory is an autonomous framework that employs large language models, or LLMs, as research assistants. For those unfamiliar, LLMs are advanced artificial intelligence systems capable of understanding and generating human-like text based on extensive training data. Given a research idea proposed by a human, the system progresses through three primary stages: literature review, experimentation, and report writing. The goal is to produce comprehensive research outputs, including a code repository and a research report. Let's take a closer look at these stages. First, the literature review stage involves the collection and analysis of relevant research papers. The system uses an agent, a specialized software component designed for specific tasks, to search databases like arXiv for pertinent papers. Now, arXiv is an open-access repository where scientists share preprints of their papers before formal publication. The agent summarizes and curates this information to build a solid foundation for the research. The next stage is experimentation. Here, the Agent Laboratory employs what they call the MLE solver. This module is designed to generate, test, and refine machine learning code autonomously. Machine learning, in case you're wondering, is a branch of artificial intelligence where algorithms learn from data to make predictions or decisions without being explicitly programmed. Essentially, the MLE solver writes code based on the research plan, runs it on datasets, observes the results, and iteratively tweaks the code to enhance performance. The final stage is report writing, facilitated by another module known as the paper solver. This agent assembles insights from the literature review and results from the experimentation phase into a structured research report. The report follows the standard format of academic papers, including sections like the introduction, methodology, results, and discussion. One might wonder about the effectiveness of such a system. The researchers evaluated the Agent Laboratory using various state-of-the-art language models, namely O1 Preview, O1 Mini, and GPT-4o. These are different AI models with varying capabilities that power the agents within the system. They invited human researchers to assess the quality of the outputs. Interestingly, they found that the Agent Laboratory powered by O1 Preview generated the best overall research outcomes. In numerical terms, the usefulness was rated at 4.4 out of 5, and the report quality at 3.4 out of 5. Moreover, the experiments conducted using the generated machine learning code achieved performance comparable to existing state-of-the-art methods. Another significant finding was the impact of human involvement. When humans provided feedback at each stage, what they termed co-pilot mode, the overall quality of the research improved notably. For example, the average overall reviewer score for papers increased from 3.8 out of 10 in autonomous mode to 4.13 out of 10 in co-pilot mode. This suggests that while the agent laboratory can function autonomously, human guidance enhances its effectiveness. A critical aspect of this framework is cost efficiency. The agent laboratory achieved an 84% reduction in research expenses compared to previous autonomous research methods. To put that into perspective, the cost to generate a research paper using the GPT-4o model was only $2.33 USD, whereas previous methods cost around $15 per paper. It's also worth noting how the agent laboratory performed on standard benchmarks. Using the MLE solver, the system tackled a set of real-world machine learning challenges from MLE Bench. MLE Bench is a benchmark derived from Goggle competitions. Goggle, for those who might not know, is an online platform where data scientists and machine learning practitioners come together to solve complex data problems and compete in predictive modeling contests. The Agent Laboratory earned more medals, including gold and silver, than other solvers like MLab, OpenHands, and AIDE, demonstrating its capability to solve practical machine learning problems effectively. The researchers acknowledged some limitations, such as occasional challenges with following instructions during the literature review phase and tendencies for the system to generate code that doesn't execute properly on the first try. However, they view these as opportunities for future improvements. In conclusion, the Agent Laboratory represents a significant step toward automating parts of the research process, allowing scientists to focus more on creative ideation and less on tedious tasks like coding and writing. By leveraging LLM agents effectively, this framework has the potential to accelerate scientific discovery and make research more accessible and cost-effective. Thank you for joining me on this exploration of the Agent Laboratory. I hope this discussion has shed light on how AI and autonomous agents are reshaping the landscape of scientific research. Until next time, keep pondering the possibilities that technology brings to our ever-evolving pursuit of knowledge.